When we have variable terms on both sides of our equal sign, which we have not seen yet, we've only seen just a single constant term on the right-hand side so far. When we've got variable terms on both sides, we've got to use our inverse operations on them to get all my variable terms to one side. Kind of messed that up. That says one side, sorry. And all my constant terms to the other side. So we're going to stick with our highlighting today. I'm going to do my variable terms in yellow, my constant terms in pink. We're going to see that they're going to be kind of mixed up on the left, mixed up on the right. And we've just got to bring all those yellow terms to the left, all those pink terms over to the right, and then solve it from there. Sounds scary, but it's not. Let's jump right in with an example while you're finishing that up. Let's say we've got 5x plus 4 equals 3x plus 10. Five x plus 4 equals 3x plus 10. Whenever we start out solving an equation, what's the very, very first thing we want to do with this?
Line down the equal sign.
We're going to draw a line through our equal sign. And today it's going to be even more helpful for us to do that, right? Because this whole process that we're going to work through is bringing every variable to the left, every constant to the right. We definitely have to know which side is the left, which side is the right. That's what this line helps us do. Now, I've got 4 total terms in this equation. What are my variable terms here? 5x and 3x. And then, Darius, what are my constant terms? 4 and 10. So with your 2 colored highlighters, doesn't matter what color they are, make sure 5x and 3x are the same color. And 4 and 10 are the same color. We can visually see that we've got 2 unlike terms on the left, 2 unlike terms on the right. We're going to have to do some inverse operations to get both my variables on one side and both my constants on the other. And let's start with my my variable term here. I've got 5x and 3x. And I want to move my 3x over to the left. How can I do that? What would I need to do on both sides here? Is my 3x here positive or negative? It's positive, right? So what's the opposite of positive 3x? Negative 3x. I'm going to write that directly under 3x. And I'm going to write it directly under 5x. Don't write it underneath the 4 because we can't combine that variable term with the 4. We can combine it with the 5x though. I'm going to draw my line under all that. What happens to 3x minus 3x? Cancels out. What would 5x's minus 3x's be? 2x. Plus 4 equals 10. Now I've got one single variable term on the left. Any ideas on what I can do now? Subtract 4. We brought that yellow term over to the left. Let's do the opposite and bring this pink term over to the right and join it up here with that 10. The opposite of plus 4 is minus 4. We're going to write that directly under my 4 and my 10. Cross out the 4's. Leaves us with 2x equals, what's 10 minus 4? 6. All right, and I'm keeping everything in line here. I know there's some weird gaps and spaces in there, but if we keep everything in line, it's going to help us stay organized. And we did it. We've got one single variable term in yellow on the left, one single constant term in pink on the right. Once we've got that sorting done, our balancing is over. What can we do to get x all by itself? My last step. What do I have to do on both sides here? Divide by 2. So I'm going to keep saying this like I've said before. Every single lesson we do here, we're building and building and building. A lot of this is the exact same thing we've been used to seeing. The only difference is now we've got an x on the right as well as an x on the left. What happens with this 2 over 2? Cross it out, leaving me with x, and 6 divided by 2 leaves me with what? 3. There's our answer. X is equal to 3. So notice my line through the equal sign extends all the way down till we get our answer. Every time I perform one of these inverse operations, I'm drawing a line underneath my entire equation so that we can see this is the result of subtracting 3x. This is the result of subtracting 4, and this is the result of dividing by 2. A lot of people that were getting kind of confused and making mistakes over the last couple of worksheets, I noticed we're not drawing these lines underneath our inverse operation. We got to do that, especially when we're starting out, to make things a lot more clear for us. This is nice and neat, organized. Every term is in line with another. Straight through, x is equal to 3. Let's kind of explain what we did here. Quick little show of thumbs up, down, sideways, how we feel about that process. Thumbs up makes total sense, just like what we've been doing. Thumbs sideways if it's kind of okay. Okay. We're out of here at what, 25, right? Something like that? 26? Okay. Just want to make sure we're good on time. So the first thing we did was brought the variable term over to the left. We brought the constant term over to the right next. And then we did our last step of dividing to get x all by itself. Questions I could answer about that process? I know we're going kind of quick, but it is Thursday, and I want you guys to have time to work. Good news is our worksheet doesn't have a backside today, so it should be pretty straightforward. Let's take a look at another example. Let's say we've got 6y minus 2y minus 3 equals 3y plus 8. I'm going to split my equal sign just like that before we start highlighting. How many total terms do I have in this equation? On the whole equation, left and right side, total terms, how many do I have? 5 of them. Good morning, sir. I got 6y, negative 2y, negative 3, 3y, and 8. So because I have more than 4, I know that I'm going to need to combine some like terms somewhere in here. Let's figure out where that is. Is 6y a variable term or a constant term? 6y?
Oh, variable.
Variable. What about negative 2y? Variable. What about negative 3? Constant. 3y? Variable, right? Anything that's got a letter is the same type. And positive 8 is constant. We want to combine like terms first. If we look at the left side, I see I've got 2 yellow terms. Those are like variable terms. So I'm going to combine those first. What would 6y minus 2y give me? 4y. 6 minus 2 gives me 4y minus 3 equals 3y plus 8. So we're sprinkling in what we talked about yesterday with combining like terms. To start us out, now we jump into today's process. So every lesson builds on the last. Everything we've been talking about is going to be included in the next lesson, and the next lesson, and so on. So on the left, I've got a yellow term and a pink term. On the right, I've got a yellow term and a pink term. What can I move around first? The y. Am I going to bring the 3y to the left or the 4y to the right? 3y to the left. Technically, it doesn't matter. We could do either one. But whenever we write our answers, we usually have y equals the number. So just as a kind of general thing, we typically want to bring our variable term over to the left. Okay? So what's the opposite of 3y? Minus 3y. I'm going to write it under my like term over here so I can subtract them. What happens to these 3y's on the right? Cross them out. What would 4y minus 3y give me? 1y. So we brought my variable term to the left. What are we going to bring to the right? Anyone know what we're going to bring to the right? The minus 3. What's the opposite of minus 3? Plus 3. Cross out the 3's. Right? 1y. Do we need to write that 1 in front? No, we can just call that y. And what's 8 plus 3? 11. Boom. There's our answer. Same exact steps as the first example. Only difference is we had to combine our like terms first. You always want to make sure that we're combining those like terms first to get them out of the way, so that when we bring this 3y over, we're only combining it with that one variable term. If we've got two of those over here, and we try and subtract 3y, we're going to get all kinds of messed up. We don't want that. Questions on that go around? Making sense? Kind of. I see two heads shaking. Okay.